Alright, this video is on solving square root equations using tables and graphs. One way that we can solve our square root equations is to use your graphing calculator, and you can just punch the equation into y equals, and then you can look at the table or the graph and find the value of x or y that you are looking for. So we'll start with a word problem. This is a wind velocity problem. It says, in a hurricane, the mean sustained wind velocity v in meters per second is given by v of p equals 6.3 square root of 1013 minus p. Sorry, I had to add the square root in there. I forgot to put it in there before. Where p is the air pressure in millibars at the center of the hurricane. Estimate the air pressure at the center of a hurricane where the mean sustained wind velocity is 50.4 meters per second. All right, let's start with the table method. We'll start with using a table, and step one is enter the function into your graphing calculator. X will represent the pressure, and y will be your velocity. Step two, you're going to look at the table, and you're going to just hit second table and find the y value that you are looking for. In this case, we're looking for a y, which is our velocity of 50.4. But when you first hit table, if you start it with your x's or 0, your y's are all up in the 200s. So what you can do is, instead of hitting the scroll, because you can tell that these are decreasing in very small increments, you're going to have to scroll for a very long time. You could just say, all right, I know that x can't be anything greater than 1013, because that's what's under the radical sign in your equation. So I'm going to change my table. Do you see table set right here? I'm going to hit second table set and change the table start to 1013. So instead of starting at 0, now we will start at 1013, like that. Also, as a side note, take a look at this delta table, this triangle table. That means the increments that it's going to change in. We're counting by ones. If you wanted to count by tens or halves or whatever, you could change that at any point to make your x's change by just by counting by ones. So now I look at my table, and I am going to have to scroll a little bit, but it's less than before, because now I'm going to the, sorry about that, to the x's are in the 900s, and here's our y's. We are looking for a y value of 50.4, so there it is right there. And that corresponds to an x value of 949. And that is our answer. So what is the air pressure at the center of the hurricane where the mean sustained wind velocity is 50.4 meters per second? The answer is 949. And that was air pressure in millibars, so don't forget your units, millibars. That would be the answer to the question. All right, method 2, we're going to use a graph. And this is my favorite method because I'm a very visual person, and for using the graph, I can see exactly what I'm looking for. Step 1, you're going to enter the function into your graphing calculator, where x is your pressure and y is your velocity, just like we did before. But we're also going to enter y equals 50.1 in as well, and that's because that's the y value that we are looking for. So you just put them both in there just like that. Alright, once you've put those in, hit graph, and you're going to look at the graph and find where the two functions cross. And this is going to give you the x value, because the y value will be the y that we entered in. The problem is, if you hit zoom 6, or if you just hit graph, you're probably not going to be able to see the two functions. You have to use a little common sense to adjust the viewing window. So we're going to change our window. I know that y is going to go up to at least 50.4. We entered in y equals 50.4, so I made my y max 60, just so that I know that it will cover 50.4. We also know, because we've got the square root of 1013 minus x, that we know that the end point is at 1013. That's when we talked about our translations, our transformations, that's where it's going to go. So 1013, I made my x max 1200. I mean, you know, you can pick 1100 would work. You can pick something, but I just picked 1200 so that I know I'm going at least to 1013. And then you can change the scale. This is what the tick marks are counting by, x and y, just to something that makes sense. You don't have to change that, but when you hit graph now, here's what it's going to look like. And what you're seeing here this is the end of the curve. It should actually come all the way down, and that's 1013 right here. It's just a pixel thing in the calculator. And then this is y equals 50.4, 50.4. So when this curve equals 50.4, that's that point right there. We're looking for that x value, whatever that is going to be. And so to find that, you hit second calc intersect, which is right here. Second calc intersect. It's going to ask you what's the first curve that you want, and it's going to put it on y1, which is this, so you can hit enter. And then it's going to ask you what the second curve is that you want. It's going to put it automatically on y2, which is the line, and you can hit enter. And then it's going to say guess, and so you'll put your cursor about right here. It doesn't have to be perfect, but you just want to put it there and then hit enter. And then the calculator will give you the exact values where that intersects. And that'll be right here. It'll say intersection. X equals 949, y equals 50.4. So we know this is right because we already did this with the table, but that tells you right there. And I like this method better because if there's any decimals, it's going to show them, and you're going to have the exact value that you're looking for with any decimals, rather than just whatever the table is going to give you. So same answer to our question, x equals 949 millibars. And hopefully you guys understood all that, but if you don't, you can always hit rewind and watch this video all over again. That's the beauty of the videos. All right, see y'all tomorrow.